Hello everyone, this is Dr. K. Ramya. Today we are going to discuss about the optical fibers. So introduction of optical fibers and what is the principle underlying in the optical fibers. So let's get started. So how does the name that the optical fiber come from? So the word fiber comes from the Latin word fibra. Fibra means a thin thread-like piece of material. So now when we deal with optical fibers, our fiber will also be in the form of a very thin material, right? So that material is used to carry the light waves. So optical means light, fiber means the very thin material or thread-like material. So optical fiber is a thin and transparent guiding medium, dielectric medium, or it's a material that guides or transmits the information as light waves. So optical fiber is a material which carries the information in the form of light waves. Here we are saying it as a medium. Medium means which acts as a which carries the information. So from one end to the another end. As it is an optical fiber, it carries the light, it carries the information in the form of light. So here we are telling it as a dielectric medium. Why we are calling it as a dielectric medium is that the material which we are using for transformation of the information should not be conducting, because the information, if it is a conducting material, the information may get distracted or there will be distortion of the signal, and hence we are choosing a material which is non-conducting, and hence we are calling it as a dielectric medium. So fiber optics is a branch of physics, branch of optics, that deals with the study of propagation of information in the form of light through transparent dielectric. So wherever you say it as an optical fiber, there we are saying it as dielectric to make sure that the medium is not conducting. So optical fiber is a thin transparent material or a dielectric medium that guides the light waves So what is the principle underlying in the optical fiber? It is what I call as total internal reflection. So what is a total internal reflection? The name itself indicates that, so internally reflected, totally reflected. So the light which we are giving into the optical fiber is itself reflecting inside, that is totally. How much ever light we are giving, that much light is getting reflected. For example, when we take light travels from denser to rarer, we always say the light ray travels from denser medium to rarer medium, and if the angle of incidence is greater than the critical angle, so then the light travels totally. So for the total internal reflection to occur, means whatever light we are giving, that is reflected internally inside the material. So for that condition to occur, what are the prerequisites? First one is that the light ray should travel from denser to rarer medium. Another one is that the angle of the incidence should be greater than the critical angle. If these two happens, then the phenomenon of total internal reflection takes place. Let us see in the form of a diagram how it happens. So there are three conditions. So we are talking about two mediums. One is denser medium, another one is rarer medium. For the denser medium, let us take the refractive index as N1. For the rarer medium, the refractive index is N2. So now we are incidenting the light, right, from the denser medium. So light travels from denser medium to rarer medium, and the angle of incidence should be greater than critical angle. In the first case, what happens is that we are incidenting the light. So this is the incident light. So when we are incidenting the light, I is less than theta c. So angle of incidence is less than theta c. So here total internal reflection does not take place. What happens is that when the light travels from the denser medium to rarer medium, it gets bended. So that is what we call as refracted ray. So second one, what is the second category? When I is equals to theta c, when angle of incidence is equals to critical angle. So when we are incidenting the light, so the angle of incidence is equal to critical angle. If the value, what happens is that it is equals to theta c, then the refracted ray will passes at the border of N1 and N2. So denser to rarer medium interface it passes through. So N1 is core, N2 is cladding. If we take that way is also okay. or else denser to rarer medium, the light passes through the boundary. So third condition, now I is greater than theta c. So now we are incidenting the light. So the light is going and hitting at the boundary. Then instead of refracting, as I is greater than theta c, that is angle of incidence is greater than the critical angle, the light is getting reflected into the denser medium itself. So this is what we call it as total internal reflection. So the two conditions of having the total internal reflection is the light should travel from denser medium to rarer medium, and the angle of incidence is equals to critical angle, right? So as we have already seen that n1 is greater than n2, always n1 should be greater than n2. That is the refractive index of denser medium is greater than the rarer medium. I and O are the angle of incidence and refraction respectively. Then by Snell's law, n1 into sine I is equals to n2 into sine R. So from that equation, now we are taking I is equals to second category, I is equals to theta c and R is equals to 90 degrees. Then what happens? N1 sine I is equals to N2 sine 90. Sine 90 is 1. So N1 sine theta c is equals to N2 sine theta c is equals to N2 by N1, or theta c is equals to sine inverse of N2 by N1. Now let us check if the rarer medium, that is N2 is equals to A1, that is if the rarer medium is air and the refractive index is 1, theta c is equals to sine inverse of 1 by n1. So this is the explanation of the optical fiber with its principle total internal reflection. Thank you.